Alright, hello. Today's lesson's over 9.1, Intro to Circles. By the end of the lesson, we should know the parts of a circle and know how to name them. Our first point is going to be, or first part, is going to be the center of the circle. It is known as the center point, and this point is equal distant from each point on the circle, meaning that from the center to the edge of the circle and all around the edge, every point should be the same distance as that center point. If we were to connect these 2 points together, we would form what is known as the radii. So from the center point to the edge, the segment that is formed is known as the radius. If you have multiple, they are known as radii. So the segment from the center to a point on the circle is the radius. And we see that right here where I go from the pink, which was our center, to the edge of the circle along the green line, and thus forming the radius. The next thing that we should focus on is what happens when we go from one side of the circle to the other side of the circle while going through the center point. This is known as the diameter, and it is a segment that passes through the center and connects the 2 points on the circle. So a segment that passes through the center and connects 2 points on the circle. And we're going to deem that yellow. So this line right here, you see how it goes from one side of the circle to the other side, and it goes through my center point? That is our diameter. And the next thing is a chord. A chord is a segment that connects 2 points on the circle. Okay? So it is the segment connecting 2 points on the circle. And we call that a chord. Okay, so now that we know the parts of the circle, we are going to practice on the circle below and name some of them with our various things. So, let's see what we have. Sorry, I'm going to adjust my camera a little bit. There we go. Okay. So, we have, it wants us to name the circle. Well, in order to name a circle, we name the circle by its center point. So this is going to be circle, and our center point is A. So circle A. When we name the radii, so if we're naming the radii, let me highlight our center point again in pink. So our radii, which I'll do in green, are going to be all the different points from the center point to the edge of the circle. So I have AC, I have AD, I have AE, I have AF, and I have AB. All of those are our different radius or radii. So we have AB, AC, AD, AE, and AF. All line segments from the center to the edge of the circle, thus making them radii. Now for the diameter, we have 2 diameters. We have diameter CF and diameter BE. Okay, remember the diameter is a line that goes through the center point to the opposite side of the circle. Okay, so we have BE and CF there. Now we have to name the chords. Well, our diameters are a type of chord because it's a segment connecting 2 points of the circle. So we can have BE again and CF. But we also have GC or CG. Okay, so we have CF, BE, and CG. Now the next part is kind of interesting because it says if BE is equal to 16, find AE. Well, BE is here and AE is here. Well, if you notice, BE goes through the center point and it takes up the whole circle, whereas AE goes to the center point and it only takes about half. So AE is a radius and BE is a diameter, so we can write the equation that diameter is equal to 2 times the radius. So if my diameter BE is 16, that's going to equal 2 times AE. So I need to get AE by itself by dividing by 2, and I find out that AE is equal to 8 units. So my AE, or my radius, is going to be 8. The next question says if AF is equal to 5, so AF here is equal to 5, find AD. Well, if we notice, both AF and AD are radiuses, and radius equal each other because they're both equal distant from the center point to the edge. So if AF and AD equal each other, then 5 is equal to AD, or AD equals 5. Now the next one says if AE is 7, find CF. Okay, well, once again we see that we have a radius, which is our AE, and we have CF, which is a diameter. So if we use our equation we had earlier of D equals 2 times the radius, then we can see that when I plug stuff in, I'm going to have CF is equal to 2 times AE, which in our case was 7. So CF is equal to 2 times 7, which means CF is 14. The last question is, does GC equal CF? And our answer is no. Okay? The reason GC does not equal CF is because GC is a chord that doesn't go through the center point, whereas CF is a diameter and does go through the center point. So GC, since it doesn't go through the center point, I don't have enough information to tell me if it is the same as CF. And by looking at it, we'll notice that it is not. So a chord does not equal a diameter. And so knowing that, we now know the parts of a circle and the types of questions that we can be asked that will involve the various parts. Okay? This would be a great time to pause the video so that you can fill in your notes. The next part of the video will talk about how to name the various parts with arc and major arc and semicircles, and how to solve the various pieces. Okay, the next part of the notes is the minor arc, semicircle, and major arc, and how to name them. The first one we're talking about is the minor arc, and the minor arc is the measure is less than 180 degrees. It is critical that we know that it is less than 180 degrees is a minor arc, which means that it does not have a diameter. If there was a diameter, it would be 180 degrees. And so what we see here is that this little thing here is known as the arc symbol. So when we see that, we want to know what the arc is. And this greater than sign or less than sign that y'all like to call it so much is known as the angle sign, and that this measure of angle BAC is going to be known as the central angle. Okay, we call it the central angle because the A is at the center of our circle. And what we're going to find out is that the center angle, which is represented in pink, is going to be this angle right here, BAC. It goes into the circle and forms an angle inside the circle, and we find out that this one is particularly 135 degrees. However, we also have a minor arc, which we'll represent in green, and our minor arc is BC. Okay, minor arcs are named with two, so named with two letters, unlike its major arc brethren. Okay, so our minor arc BC is going to be the same as our central angle and vice versa. Whatever our arc measures will be the same as the central angle, and whatever the central angle is, it will be the same as the major or minor arc. Okay? The next thing coming up is the semicircle, which is the measure is exactly equal to 180 and equal to its central angle. Okay? What that means is that it is essentially a semicircle is the diameter. When we have a diameter, a semicircle is formed. It is the line that cuts a circle in half. Okay? So, with that being said, our semicircle, which we'll do in yellow, is represented as such. So the yellow is our semicircle arc, which is equivalent to the central angle, so that they should both be 180 degrees. Once again, my central angle is in pink, and as you see, it's a straight line, and if we know anything about straight lines, they are worth 180 degrees, aka forming a straight line. And the major arc that is formed is no longer less than 180, so we have to name it with 3 letters. Because major arcs and semicircles are named with 3 letters. So we would call this major arc GHF, and the measure of it is going to be the same as our central angle and vice versa. Lastly, the final part of this page is the major arc, and the major arc is a measure is greater than 180 and it's equal to its central angle. So in this case, our major arc is going to be here with our central angle, and we'll do our major arc in purple so we know that it's different. And so the major arc is going to be BCD. Well, we know that in order to find the major arc, we need to subtract out the minor arc, and if we remember, our minor arc was 135 degrees. So in order to find the major arc, I'm going to take 360 degrees, because all circles add up to 360 degrees, and subtract the minor, or 135 degrees. So I'm going to take the total degrees and subtract the minor arc in order to get the major. And when I do that, I get a major arc that is 225 degrees. Okay? Remember, major arcs, like the semicircle, are named with 3 letters so that they can be identified in a circle and not be confused with minor arcs. Okay? So our circle here is BCD, or our circle is circle A, but our major arc is going to be BCD with all 3 letters. These are the 3 types of things that we are going to start with in our circles unit: minor, semi, and major arcs, okay, as well as naming the various parts of the circle. This will be a great time to pause before we do some practice problems. Make sure you fill in your notes. They'll be used on your tests. Okay, let's do a couple of examples. So here I have a picture, and it says that EC is a diameter. So I'm going to highlight the diameter in green and then cross EC as such. Remember, a diameter is a segment that goes from one side of the circle to the other, but goes through the center point. So knowing EC is a diameter, I can then come in and say, okay, the measure of BAE. So let's do BAE in yellow. So I'm going to highlight BAE in yellow, and then I go B to A to E. So this part right here is going to be 40. Let's put a 40 in there. Okay, and it says angle, so it's going to be this angle down here, which means that the arc EB, so the arc here, is also 40. Okay, because the angle and the arc are the same. And then we see, okay, and the measure of arc CD. So we'll do that one in pink, just to make it different. So CD is going to equal 100. So again, we have the arc of CD, and it says that it is 100. And if you remember, like I said just a second ago, the arc and the angle, so DAC, are the same. So we can say that this is also 160. Knowing all of that, it asks us to find the measure of BE. Well, we know the measure of BE, of arc BE. It's going to be 40, because it is the same as the angle BAE. We also know BC, so BC is here on this side, and since EC is the diameter, then I know that from E to C, so from E all the way to C, that is a semicircle, which means that it's 180 degrees. So to find BC, I have to do 180 minus the minor arc that I already had, which is 40, which gives me 140 degrees for BC. Now BAC, which is this inscribed angle here, is the same as the arc of BC, because arcs in the angles in the central angle is going to be the same. So BAC is also 140. Now we need to find the measure of DE, arc DE. So by doing that, we do the same thing that we did for the arc of BC. We're going to take our 180 and subtract out our minor arc of DC, which was 40. Nope, just kidding, 100. And we find out that that is going to be 80 degrees. We can keep going and practice with the measure of DAE. So DAE, we have this piece. Oh, it's an angle, and I already found the arc of DE, so I know that this is going to be 80, because the angles in the central angle and the arcs, minor or major, are equal to each other. I now have the DB arc. So if I know that DE is 80 and DB and EB is 40, well then I need to have DE plus EB equals DB, and so I get 40, or 80, sorry, plus 40 is equal to 120. So DB is going to be 120, which means that angle DAB, now that I know arc DB and they are the same, is also going to be 120. And then lastly, we're looking for DC, and DC is going to be the same as our inscribed angle, which was 100, or DAC, which was 100, therefore making this 100. Okay? We'll do one more example here. Okay? So we have this middle example here where it says the measure of EAF is 110. Well, first we need to label our diameters. It says EC is a diameter and DF is a diameter. We highlight those in green to let it know. Now we need EAF, which is 110. So EAF, so right here is 110. Okay, we also need BF, which is 60, so BF right here is 60. And so now we can go through and find everything. So the measure of BE, which is right here, is going to be our total, which was 110, because remember the entire arc is 110 because the angle for the entire angle is 110. So BE is going to be 110 minus 60, or 50 degrees. Okay? BC, the minor arc of BC goes from here to here, and if we take a look at that, we'll see that this tiny piece right here is going to end up being 70 degrees because this piece was 110 and EB is a diameter. So if this is 70 and this piece right here, which is BF, and I need B to C, is 60, then I'm going to have 60 plus 70 is equal to 130, which is also known as BF plus CF equals BC. Okay? Then BAC, the interior angle, central angle, it's got its mouth open to the same arc, so we can say that this is also 130. We can then focus over here on DE, and once again we see that this little piece is just going to be the 110 minus 180. So once again we have 180 minus 110, which should equal 7D, in order to figure out what that is. Then we have DAE, which also is the same as our arc DE, which gives us the 170. Next up we have DB, which is this part right here. Okay, we already know BE. We said BE was 50 degrees. And so if that is 50 degrees and this piece right here was 70, then we can add the two together and we get 50 plus 70 is equal to 120 degrees, also known as BE plus DE to equal DB. Then we have DAB, or angle DAB, which is going to be all of the arc DB, so this should be 120 degrees. And then lastly we have DC, and so DC is down here. So here I had 130, so this whole thing was 130, and this whole thing was 120. So in order to find this little piece here, I need to take the total and subtract both. So I have 360 minus 120 minus 130, which is equal to a solid 110. Okay, our last example, we have the circle, and it says that EC is a diameter. So let's highlight our EC here. Boom, there's our diameter. Okay. It says name all of the major arcs. Oh, we did not name all of our major arcs on our previous ones, but that's okay. We'll do that now. So we need to name all, and then we will go back and we'll name all of the semicircles and we'll name all the minor arcs. So we'll wait to do that. Let's fill in the table first. So the measure of arc BE, so we need to find this little arc right here. But first let's label what they gave us. They told us that EAB, or the internal angle of EAB, is 45, so EAB. So that piece right there is 45. They also told us that the measure of arc ECD is going to be 280, so ECD, so if we're going ECD, is going to be 280, like so. Okay, now we're cooking. So the measure of BE is going to be the same that we had, so we have 45. The measure of BC is going to be our diameter part, which is a semicircle, so we're going to have 180 minus the 45, and thus end up with 135 as our arc for BC, which means that BAC is going to be the same as our arc BC because the central angle and the arc are the same. So this is also 135 degrees. Now we need to find DE. Well, if we come over here, we need to find this part right here, which is DE, which we can find by taking our two arcs, 280 and 45, and subtracting from the total. So we have 360, which is our total, minus 45, minus 280, and that equals a grand total of 80 degrees for DE, which means that angle DAE is going to also be 80 degrees. Okay, so DAE is 80 degrees because, again, the central angle and the arc are the same length. The measure of DB, which is these two angles here, we have the measure of DE plus the measure of EB, which is 80 plus 45, which gives us 125 degrees as our measure, which means that angle DAB is going to be the same as the arc of DB, which means that our angle is going to be 125 degrees. Lastly, our angle for DC, well, we could say that DC is our diameter semicircle here from EC, and we could say that, oh, it's 180 minus the DE part. So therefore, I could say 180 minus 80 is equal to 100, which is the equivalent of saying arc EC minus arc DE is equal to arc DC. Okay? Now let's go back and name all the stuff. So if we're naming all of the minor arcs, we have minor arc EB. Remember, you name minor arcs with 2 letters. We have minor arc BC. We have minor arc DC. And we have minor arc DE. Okay? Those are all of our minor arcs that we have for our first circle. We also have BC, DC, DB, we have EB, D, and we also have minor arc DB here. Okay, so we also have the arc DB. Over here where we're naming the semicircles, we have semicircle EB, EBC. We have semicircle EDC. We have semicircle DCF. We have semicircle DEF or semicircle DBF. Remember, you need 3 letters to name all semicircles. Okay? And remember, a semicircle is just half of the circle. Now down here for our major arcs, we're going to have the following major arcs. So remember, major arcs are greater than 180. So we have arc CDB, arc BCE, BCE, DCDB. Then we have arc ECD, arc E, follow it CD, and arc DBC, and arc BCD. Okay, these are all of the major arcs. And with that, that concludes everything about the intro to circles. Remember, if you have any questions when watching the video, bring them to class and ask your teacher to assist you. That's it.